In this video lesson, we're going to learn how to expand a binomial raised to a natural power to a power less than or equal to 6. All right, so we're going to start off with some that you've done before, and we'll start with a plus b squared. We're going to start by making sure that we know the answer is not a squared plus b squared. And to make sure we don't miss certain terms, I'm going to use a box to help me keep track of my terms. Up here I have a plus b, and down here I have a plus b. A times a is a squared. A times b is ab. B times a, I'm going to keep them in alphabetical order, ab. And b times b is b squared. And you'll notice that my like terms are right here along the diagonal. And so I then get a squared plus 2ab plus b squared. All right, so the next one we're going to do a plus b cubed, which is the same thing as a plus b squared, which we just got, times a plus b. And we just learned that that was a squared plus 2ab plus b squared times a plus b. And just like before, I'm going to make a box diagram to keep track of all my terms. So I'm going to go with a plus b here and a squared plus 2ab plus b squared here. Let's see, a times a squared is a cubed. A times 2ab is 2a squared b. A times b squared is ab squared. B times a squared is a squared b. I like keeping things in alphabetical order. B times 2ab is 2ab squared. And b times b squared gives us b cubed. And just like before, we're going to get our like terms on these diagonals here. Here I have 1a squared b and 2a squared b's, and here I have 2ab squareds and 1ab squared. And when I put all my terms together, I get a cubed plus 3 of those a squared b's plus 3ab squareds plus b cubed. All right, we're going to do one more of these. This time I have a plus b to the fourth, and I realize, well, that's the same thing as a plus b squared times a plus b squared. And we figured that out in the first slide. That was a squared plus 2ab plus b squared times a squared plus 2ab plus b squared. So I'm going to make a chart that's going to be 3 by 3 to keep track of all of my terms. There we go. So I've got a squared, 2ab, and b squared. And up here, a squared, 2ab, and b squared. All right, so let's go through. A squared times a squared, a to the fourth. Here I have 2a cubed b. Here I have a squared, b squared. Down here, 2a cubed b, 4a squared b squared, 2ab cubed. Over here, a squared b squared. Then I've got, let's see, 2ab cubed and b to the fourth. And just like before, oops, get my highlighter, I have like terms on the diagonals. How convenient is that? So my final answer up here is going to be a to the fourth. Here I have 4 of those a cubed b's, 4a cubed b. Here I have 1 plus 4 plus 1, a squared b squared, so 6 a squared b squared. Here I add those two up, so I have 4ab cubes and a b to the fourth. All right, so you might be worried that we're going to do a plus b to the fifth the same way, but all of this was to find a pattern, to actually find an easier way to do this. So here on this next slide, I have everything we've done lined up, and I want you to look at the coefficients. Here I have 1 and 1. Here I have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and we see Pascal's triangle. Look at that. So what should we notice about Pascal's the coefficients? They are from Pascal's triangle. And then there's a few other patterns we want to notice. For instance, look at the A. The powers go 4, 3, 2, 1, 0. And on B, the powers go 0, 1, 2, 3, 4. And you'll notice the powers always add up here. So if it's to the fourth, the powers add up to 4. So I've got 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, and 4 and nothing is 4. Okay, so A's powers increase. No, they decrease. Decrease. Let's see, scroll this down. B's powers increase, and the sum of the powers equals n if we say that a plus b is taken to the nth power. All right, so we're going to use all of that to figure out this one, a plus b to the fifth. So first thing, Pascal's triangle, 1, 1, 1, 2, 1. I want the fifth row. This is the third row, fourth row, fifth row is the one with the 5. 1, 5, 10, 10, 5, 1. Those are going to be my coefficients. So here we go, 1, 5, 10, 10, 5, 1. I got to leave myself enough space. Then the A's start with a to the fifth, a to the fourth, a to the third, a squared, a to the first, no a. Then the B's start with no b, b to the first, b squared, b cubed, b to the fourth, b to the fifth. Look at that. We did it. Put plus signs in between, and we're done. Quick check, make sure all the powers add up to 5. 5, 4 and 1, 3 and 2, 2 and 3, 1 and 4, 5, and we have expanded a plus b to the fifth. Now, of course, we'll have some problems that get a little harder. So let's take a look at this one. We've got it to the sixth power, and it's r minus t. And we need to think of this as r plus negative t. That's going to help us out in this. And we need row 6. So let's see, after 1, 5, 10, 10, 5, 1. That was the fifth row we just used. We get 1, 6, 15, 20, 15, 6, 1. All right, so here we go. We've got 1 r to the 6th plus 6. Our r goes down to the 5th, and we're going to put negative t in parentheses to the first. Then we're going to have 15. R goes down to 4. Negative t goes up to 2. Then we have 20. R goes down to 3. Negative t goes up to 3. Still adding up to 6. That's good. Then I've got 15. R goes up to 4. Negative, no, it's not going up. You caught that, right? R is going down. So here we go. So R goes down to 2. Negative t goes up to 4. I don't have enough room in one line, so here we go. Plus, my next one is 6. R to the first, negative t to the fifth, plus my last one, 1. R to the 0, so I don't actually need to write it down. I'll just get rid of that because r went down. And then I've got negative t to the 6th. Now to write our final answer, we're going to actually simplify this a bit. So this first term is just r to the 6th. My next term, if I take negative t to the first power, my answer is going to be negative. So it's not going to be plus here, it's actually going to be minus 6 r to the 5th t. And my next one, when I take negative t squared, that becomes positive. So it's plus 5r to the 4th t squared. And my next one, because it's an odd power, it stays negative, so I don't actually want a plus there. I want a minus. So I have minus 20r cubed t cubed. And you can see this is going to alternate. Even power plus 15r squared t to the 4th. Odd power minus 6r t to the 5th. Last one's even plus t to the 6th. All right, So let's look at this next one. We've got a few more things going on in here. We've got numbers, a 3 in front of the x, and we've got a y squared. So let's see. It's to the fourth power, so we need row 4. Here's row 1, 2, 3. Here's row 4. You know it's row 4 because the second number is a 4. So let's do like we did the first time, because I think I did better when I just spaced out these numbers and gave myself plenty of room to work. So there are my coefficients. That's great. Now the 3x has to go in parentheses, and 3x starts out to the fourth, then 3x to the third, then 3x squared, 3x to the first, no 3x. All right, here I have no y squared. I'll just put a plus. Here I have y squared to the first. Here I have y squared squared. Here I have y squared to the third. And the last one I have y squared to the fourth. And I can look at my powers. 4, 4, they add up to 4, add up to 4, and add up to 4. So here I have to do 3 to the fourth. That's 81x to the fourth plus. All right, here we go. 3 cubed. So that's going to be, let's see, 4 times 27, 54, 108, x cubed, y squared, because 2 times 1 is just 2, plus. Here I've got 3 squared, so 6 times 9 is going to give me 54. X is going to be squared, and here y squared squared, that's going to be y to the fourth. Plus, okay, this is just to the first power, so I've got 12x, but when I have y squared cubed, I multiply those, I get y to the sixth. And my last one is going to just be y to the eighth when we multiply those powers, and there's our answer.